Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to be looking at the planet Venus. I will give us a quick look at where Venus is at this time of the year, but we're going to be concentrating on the planet Venus itself, not so much on our sky. Of course, we're in early February. Saturn is still there just about, but it is certainly disappearing. Jupiter is there pretty close to due south as the sun is setting, so it'll be there for the early half of the night. And as we push through later into the evening, we can see that it is close to midnight, a little after midnight, when Jupiter starts disappearing. We'll keep pushing forward into morning time, coming past familiar constellations like Leo there and the very faint Virgo here. That's Spica, so we know this is Virgo, even if the other stars aren't very visible. That's Antares in Scorpius. In fact, the moon will be very close to Antares. The small crescent moon will be very close to Antares in the next few days, so that's something you can take a look at the morning of the 5th. And there's Venus. So Venus is still nice and bright, but it's only visible quite low to the horizon at the moment. Venus is also leaving our sky. For Venus, this means it's continuing its orbit around to the far side of the sun. So even though this means more of the daytime side of Venus is facing us, reflecting extra light, it eventually draws pretty much level with the sun and disappears from our sky. So we can see there, this is past the middle of February up to the 19th, and at 7:30, Venus is invisible, but it's still there as a tiny little dot closer to 7 o'clock. Of course, earlier than that again, moving towards 6:30, even 10 to 7 there, it's basically below the horizon. So Venus is getting into a very tricky position to observe even reasonably early in the month. Even in the next few days, Venus is going to be quite low to the horizon and tricky to spot. Of course, it will stay visible a little bit longer in the countryside where you don't have to compete with light pollution, but given how low it is in the sky, the light pollution won't make too much of a difference. It's going to be hard to observe no matter what. If we take a closer look at Venus, we'll get to see more of that atmosphere. A lot of the atmosphere of Venus is carbon dioxide, but there is also a lot of sulfur dioxide and water vapor, so it does have this kind of pinkishy, maybe salmony, orangey, pink, yellowy kind of color. Of course, with the light of the sunrise here, the actual color is difficult to see. If we get rid of the atmosphere, we can see it a little bit more clearly here, kind of a pinky butterscotch. I am colorblind, so I'm not really sure what color Venus is going to appear to you, but based on what I've been told, it has a slightly pinkish color, and that is meant to be connected to its history being named after the Roman goddess of love and beauty, Venus, and the Greek goddess of love, beauty, and sometimes war, Aphrodite. So there's Venus. Venus was sometimes referred to as Phosphor or Phosphorus, and Lucifer, related to how bright it is. Lucifer and illuminate are related words, but those names are a little bit old-fashioned. Most people would call it the morning star or the evening star, and that's really what those names meant, that it was the brightest thing, Phosphor or Lucifer, the brightest thing in the morning or in the evening. Now, of course, this is us looking at the sky without any atmosphere at all. Venus has an incredibly thick atmosphere, so thick that you don't see the surface from the Earth, and if you were on the surface, you wouldn't see the stars. Now, we'll bring back our own earthly atmosphere here, and we'll take a closer look. If we zoom in with Stellarium, we've gone all the way back to January. If we zoom in with Stellarium, we don't get to see the surface of Venus because it simulates the atmosphere, and that is much closer to what we would actually see. But if you use Stellarium to travel to Venus, then you will see the surface. It gives you an idea of what the surface looks like. There we go. Oh, that's the atmosphere. So I guess I don't get to see the surface. That's a pity. But the surface of Venus is covered in volcanic structures and craters. So even though there is a lot of thick atmosphere on Venus, there doesn't seem to be a lot of erosion. And that's potentially because of the type of rain and the high temperature that Venus has. It doesn't look like we're getting to see much details of the surface. These are places where the Venera probes landed and the areas in which they landed, but without being able to see the actual surface, it's a little difficult to tell exactly what they are. But here we are, on Venus. I'll make sure that we're close to the equator and close to the middle of the planet. That's pretty close. That will do 1 degree south. That's not too far from the equator. So that means the sun, yeah, pretty much directly overhead. There are locations on Earth where the sun will appear directly overhead as well. We can get rid of the atmosphere. If you were on the surface of Venus, we wouldn't get a blue sky. It would be dark. The atmosphere is more than thick enough to block out the light of the sun pretty much entirely. I was trying to make sure that time was moving. Time has to move pretty fast for us to see the sun appear to drift across the sky, and that's thanks to Venus's rotation. The orbit of Venus isn't particularly strange. Venus is in between the Earth and Mercury, so it orbits the sun a little bit faster than the Earth and a little bit slower than Mercury, and that is exactly what we'd expect. But because Venus turns so slowly, it does appear to work a little bit differently with regards to its day and its night. A day on Venus lasts much, much longer. Depending on how you measure the day, it can last the entire year or half the year, but it does depend on how you measure the day. I just need to make sure that time is in fact moving forwards here, and it is. That's a tricky thing to make sure of on Venus because Venus rotates the wrong way. So this is time moving forward. And if we were seeing this kind of action on the Earth with the sun moving from west to east along with the planets, well, we'd think time was moving backwards. On Earth, everything moves across our sky from east to west because of the way that we rotate. Venus rotates retrograde. It's moving the opposite way. I've talked about retrograde motion in these videos before. I'll just get rid of some of the graphs there. I've talked about retrograde motion in some of these videos before, talking about planets like Mercury and Venus. Let's move time backwards. So strange to see things going apparently the wrong way. And we'll move time forwards again here at a good clip. Because Venus is so much closer to Mercury and so much closer to the sun, there's a much bigger apparent gap between Mercury and the sun on Venus. So that means from Venus, Mercury stays visible for much longer in the evenings. We can see here that the planets all seem to be moving a sensible way for them to move, albeit backwards. But if we move a little bit faster here, Mercury doesn't quite catch up with the sun on this Venusian day or this Venusian year. We've gone all the way back to last year here. Let's move forward again. None of the planets actually orbit around the sun backwards. So we can see something like that happening here with Mercury. If we move back in time, we can see that Mercury moves in towards the sun and then out the other way and then starts catching up with the sun again. So that might be a little bit more clear if we keep everything else kind of still in the sky. So we'll move time backwards, which for Venus means east to west. Very strange to see that happening. So there's Mercury pretty much behind the sun. And as we move time forward, we'll see Mercury will drift away from the sun and then start catching up to the sun again. So even though the planets may appear to move backwards in the sky, they don't. That's only because of our perspective from the Earth or from Venus. Venus, however, does rotate backwards. Venus is turning in what we would regard the wrong way. It's turning clockwise as it goes around the sun if you're looking down on it from the north rather than anti-clockwise. So Venus does behave in a bit of a strange way. And to highlight that, this is sunrise on Venus. If you're pretty much in the middle of the planet, here's the sun rising on the 14th of January 2024. And we'll go all the way through one Venusian day. And there we go, sunset on the 3rd, on the 11th of the 3rd, on the 11th of March. So it's a few months for the sun to cross the sky here on Venus. That's kind of a normal day at the time it takes for the sun to kind of pass across the sky. And the Venus will point back to the sun after a full rotation. So coming back to something like this, the equivalent of a 24-hour day on Earth from midday to midday on Venus, all the way through to 2017 there, so that's very far. But Venus because of the fact that it rotates what we would call the wrong way, things can be a little bit complicated. And we're here looking pretty much at the ecliptic. We can see there's Jupiter, there's Gemini, the twins. We can see that same line in the sky that we would have here on Earth, where we see all of the planets on the ecliptic. It's also where we would see any eclipses, even on Venus. I've gone all the way back to 1999 there. Let's fix that. Even on Venus, you would see eclipses on the ecliptic, but Venus doesn't have a moon, so unfortunately there's no eclipses to see. There's nothing going around Venus to block out the sun. We don't know exactly why Venus is turning the wrong way compared to every other planet, and it does seem to be turning the wrong way. Thick atmosphere of Venus might be part of it. The atmosphere of Venus might be slowing it down. Of course, the gas around the planet moves at a different speed and often in a different way to the solid surface of the planet. Okay, we're back to 2024, but we're still months into the future. Yes, hopping through Venusian days makes things happen very, very quickly. Yeah, so here we go from the 6th month at midday back to the 2nd month at midday. That is one Venusian day. And I'm saying Venusian. It sounds a lot like Venetian, but that is if something is from Venice, and they are both better options than venereal, which is something to do with Venus as well. For reasons that may not be obvious, but I won't make them obvious. Suffice it to say that the word venereal stems from the word Venus. So here we can see the Sun, Earth, Mercury all together in the sky, and they're all lined up on the ecliptic as we would expect them to be. So Venus is a very strange planet. There is a chance that Venus was knocked on its side. There is a chance that Venus originally rotated prograde and was either slowed down by a massive collision or literally knocked upside down. What is Venus's North Pole today may once have been its South Pole. It may have originally rotated the right way but got knocked over. Or it could be the atmosphere, the effect of the atmosphere turning at a different speed to the planet. So it's certainly a very strange sky, and trying to count days and years on Venus can be very, very strange, but that is the view that we would get, and it would be a great place to see the others. We're so close to the sun, Mercury appears nice and far out from the sun, so Venus would be a great place to observe it, and the Earth. I won't go through a whole year on Venus because that would take almost as long as a whole year here on Earth. It is over 200 days. And of course, on Venus, with a surface temperature of over 400 degrees Celsius, the sulfuric acid that falls from the sky doesn't even hit the ground. That is thought to be one of the reasons why there's not much erosion visible on the surface of Venus. If Venus gets a crater, the crater tends to stick around. There probably is volcanism on Venus, though it might not be particularly powerful anymore, and the sulfur dioxide in the atmosphere combining with water vapor, that gives us sulfuric acid, which would do a great job eroding the surface if it ever actually hit it. But with temperatures of over 400 degrees Celsius, the sulfuric acid boils before it ever hits the ground. So there we go. That'll bring us back to Earth, and it will bring us back to the same location on Earth as we were on Venus. So that's pretty close to the equator, maybe a little under the equator. We'll hop back to the default location of Cork City. There we go. And we've moved all the way through to pretty much the end of the month, and I am indeed all turned around here because we're a year ago. This was last year, so let's hop all the way forward to now to finish up. Here we go. That's a little bit better. Mars wouldn't be visible in the evening sky this year, and there is Venus, definitely very hard to see here on the 19th. So I hope you enjoyed this quick look at Venus and some of its strangeness and the view from the surface of Venus. We may get a chance to look down on Venus's orbit using the Solar System Observer in the near future. And if you'd like to see that, then make sure to subscribe to this YouTube channel so you're more likely to be suggested these videos. And if you enjoyed the video, please do like it so that I and YouTube know that you liked it. You can also take a look at a short write-up of this information on my website, queebeanscontent.ie, and I am also on Instagram under queebeanscontent. That's one way that you can be notified of videos as well. If you follow Queebeans Content, I will always put something up when I'm putting up a YouTube video. So I hope that you enjoyed this trip to Venus, and hopefully I'll see you next time.